Once again, we're going to look at the image from a diverging lens whose focal length is going to be a minus 20 centimeters. So we know this is going to be divergent because we have a negative here. However, this time the object is going to be inside the focal length or inside the focal point. So you have the mirror, object, focal point. All right. So let's describe the image for this. So the inverse of the distance of the image is going to be the inverse of the focal length minus the inverse of the distance of the object. So let's plug our values in. So this is equal to 1 upon a negative 20 centimeters minus 1 upon 10 centimeters. The common denominator in this is going to be 20. So this is equal to a negative 1 over 20 centimeters minus 2 upon 20 centimeters. Or this is going to be equal to a negative 3 upon 20 centimeters for the inverse of the distance of the image. Now the distance of the image is going to be equal to a negative 20 centimeters divided by 3, which is equal to a negative 6.7 centimeters. So what we found out here now is that since that's negative, we know that the image is going to be virtual, which means that it cannot be displayed on a screen. If we look at the magnification of the image, this is going to be the distance of the image divided by the distance of the object. And so don't forget the negative. Now the distance of the image is going to be 6.7 centimeters divided by the distance of the object, which is going to be 10 centimeters. And what we end up getting here is, oops, I forgot my negative there. This becomes positive, positive, so this is equal to 0.67. Now because it's positive, that tells us that the image is going to be upright. Now, since this is smaller than 1, we know that the image is going to be smaller than the object. So what we've discovered is that the image is going to be negative. It's always going to be negative when we're dealing with a diverging lens. Now, because the object is inside the focal point, we know that it's going to be upright and it will be smaller than the actual object. If you have any questions on the thin lens equation or the converging diverging lenses, please let me know. All right.